All right, let's get started with balanced parentheses. How did people find this particular challenge?
Easy till I got to the last four tests, and then I just could not figure it out at all.
Mm-hmm. Yeah. This particular challenge, when I was interviewing to work for Platoon, they had me whiteboard it, and I thought I was going to die. So it's a it's a toughie, and I'm going to it's I want to let you know this happens a lot, that if a challenge seems like we make it easy, remember that Tom and I have done these challenges multiple times. So when we coded out, we also had to struggle with it the first time we did it. We just did it once, and now we know how it works.
I still
So,
struggle after every time I try to do it.
yeah. So keep that in mind. So I'm going to share my screen. All right, so balanced parentheses. So we need to write an algorithm that takes in a string and returns a string with only the balanced parentheses, meaning everything that isn't a balanced parentheses should be, any unbalanced parentheses should be left out of the returned product. So it'll only contain letters, numbers, and parentheses. So these strings get returned back as is because all of these parentheses are balanced, meaning, okay, this one pairs with this one pairs with this one, etc. But then we have something like this, which has an unbalanced end parens right here. So need to return the one that without that unbalanced parens. This one should return an empty string because it just has two unbalanced ones, meaning this one does not pair with this one. These ones don't have a second pair at all, anything like that. So this isn't just saying, okay, is it balanced or not? This is saying we need to edit a final string to make it unbalanced, to make it balanced, excuse me. So I'm going to do this one in Python. So I'm going to first make balanced parentheses .py and balanced parentheses spec.py. I'm going to just define a method called balanced parentheses, which takes in a string. And then over here, I'm going to say from balanced parentheses, import balanced parentheses. And I'm going to import unit test, and we can write some test code here before we even get started on the problem itself. Call this test balanced parentheses, unit test dot test case. And we could say, we can copy all of these. Let's call this, oh, they use balance, and that's a lot better than balanced parentheses and typing that over again. So I'm just going to quickly rename this to balance and make sure that's updated too. There we go. That's a lot more elegant. So we can say def test already balanced, so we can get some of the examples that are already balanced, and so we don't need to change anything. So I'm just going to copy all of these three right here, or four even, because these three are already balanced.
It looks like numbers 2 and 3 have a trailing closed parentheses that make them imbalanced.
Oh, yeah, you're right. Thank you. All right, def test unbalanced. Looking at the README is what I should be doing. All right, of course, I'm not actually, obviously these don't have any test case yet. These are just expressions. So let's actually set up some unit tests here. So I think here we can use assert equal. Like so. A, B, oh, A, D, B, V, B, C. Assert equal. Balance, and this one should be A, oh, A, B, C, and close parentheses. All right, take on a few more of the examples here. So we have a bunch of things that are just parentheses. So we could say def test only parentheses. Self.assert equal. We know this one's going to be, if we do it like this, it should return an empty string. Oops. We need to call in the balance method. Balance with a bunch of left parens. Should give us an empty string. And then if we do self.assert equal balance, and we can give one that's like it should give us something like that. All right. Any questions about this unit test? And I'm just making sure I have that if name equals main here so that when we actually call on it, it runs. Do these tests seem like they give us adequate coverage to make sure this thing works?
Yeah, I think so.
Okay, and I'm going to run the test suite just to make sure it works at all. All right, we ran 3 tests and got 3 failures like we thought we would. So now we can start getting to work on balanced parentheses and figure out how the hell we're going to do this. So I'm going to show you one method that I found that works. I'm sure there are many great methods out there, but this is kind of the one that works best for me and allows me to illustrate a concept that is important to understand generally for coding interviews. So first I'm going to say I'm going to write a function balance that takes a string as a parameter. And I'm going to, right here, I'm going to put an example string as a comment just so I can have an example here. So I do A, B, C, A, B, something like that. And I want this to return ABC, AB, and then it should have yeah, I think that's what the balanced version looks like, right? Because we have 1, 2, 3, 1, 2, and we should get rid of that one. I'll put an extra end parens there just to kind of show, okay, here's like a very strong example. And so what I need to be able to do is I need to be able to go through this string, and I need to say, okay, can you stay? If you're a parens, that's the singular, can you stay or should you go? Now, in without worrying about, how do I know that a pair of parentheses can stay? In just general terms.
If they have an opener and a closer.
Yeah. So anytime I see an opener, I need to check, okay, does this one have a closer? So I would say, okay, here's an opener. Keep going. 1, 2, 3. Here's a closer. Okay, these two can stay. All right, here's an opener. Here's a closer. Those two can stay. Then the next one says, okay, here's one without an opener. Okay, we know this is a bad one. Go here. All right, we have an opener. Then we have another opener. We don't know if they have closers yet. So we have 3 openers in a row. We don't know if they're good or bad yet because we haven't checked for a closer. And then I say, okay, here's one closer, meaning that, okay, this one matches that one. And here's another closer, meaning that one matches this one. But this guy right here doesn't have a matching closer, so we know he's a bad one too. And this is one of those things that, like, as a human being, we can see, okay, I can tell just by looking at this thing which ones are bad and which ones are good. A computer needs, a little more, a way of checking, okay, how does this work? It can't just look at the entire string, it needs to go through it individually. And to do that, what the solution that I found was creating a type of data structure known as a stack. Has anyone heard of a stack before?
I've heard of it before.
Mm-hmm.
Isn't it just like an array?
A stack is like an array, yes, but there is a difference. And do you know what the difference is?
You go like first in, first out. Like there's different ways to put data in and take it out.
Yes. So a stack, you can think of it like a stack of playing cards, which I happen to have right here. So if I add things to my stack, da-da, 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 as if this were an array, I could just remove any card I want from here. But this isn't an array, this is a stack, meaning the first card that I can remove from this is the last one that was added to it, like so. I'm not allowed to deal from the bottom of the deck or the middle of the deck. I have to get the last one, the top one. So this parameter is called last in, first out, meaning, okay, the last thing to enter it is the first thing that I can remove, and I can only do it that way. This data structure is not necessarily, we're not going to use a literal one. We're going to use an array to simulate one, but it's very useful for certain solutions. Like, okay, if I have a stack of left parens, I can say, okay, this one is good. I can add it to the left paren stack. Then I'll go through it and say, okay, here's a right one. Since this is matching, I can just remove this one from the left paren stack. And then I can keep going and just say, okay, add things to the left stack. And if it has a matcher, remove it. And if I find something on the right stack, a right parens without a matching left thing in the left stack, I would add it to a different stack for right parens. And the idea is, if it's already balanced, I'll have 2 stacks, right and left. Both of them will be empty if it's already balanced. Any of them that are caught in either the left stack or the right stack, we know are bad. In order to do that, we're going to need to be able to know what its index number is, because what I'm going to do is I want to store the index numbers of everything that's bad and then remove them in the final product. Is this making any sense at all? Because I know it's a lot of words that I'm throwing at you right now. What questions do you have about stacks before, even though I haven't really demonstrated them yet, per se? All right, so what I'm going to do then is I'm just going to go ahead and keep on pressing on with this this function, this method. And if at any point it's not making sense, please let me know so I can qualify it. So going on with my pseudocode, I'm going to say define right stack and left stack as empty arrays. And then I'm going to iterate through the string. And I'm going to say if character is a left parens, add its index to left stack. If a character is a right parens, then I'm going to check if there is a matching left parens in left stack. If there is, remove matching left parens from left stack. If there is not, add index of the right parens to right stack. So at the end of this iteration, I'll have two of these arrays, these stacks, which will have certain index numbers in them or not. Then I want to say combine left stack and right stack into bad indices. So I'm going to combine these two arrays into one big array that has all of the indexes that I know are bad. And then I'm going to define an empty string, define a return string as an empty string. Then I'm going to iterate through the original string again. And I'm going to say if index of char is not in bad indices, add it to the return string. So we have this list of all of the indexes we don't want to keep. So if it's not a bad one, we add it to that. And at the end, we return the return string. So kind of breaking it down again, I loop through it once, saying, okay, if it's a left parens, add it to the left stack. It is. We found a matching one on the right stack, so we remove this one from the left stack. Do it again here. These two match. And then say, uh-oh, we have a right one, but there's nothing in our left stack. So we add that to the right stack. And then we keep going. Add one to the left stack, add one to the left stack, add one to the left stack. Here's a right one. We keep on removing things from the left stack, remove one, remove one. And at the end, we have two stacks, one with this one's index number and one with this one's index number. And then we loop through the entire string again and say, okay, if you have one of these index numbers, you don't end up in the return string. All right, what questions do you have about this solution? Because again, I know this is a lot.
Noah, where do you define bad indices?
Where did I do that? I said combine left stack and right stack into bad indices. So
Okay.
I would be an easier way to say that would be bad indices equals left stack plus right stack.
Got it. So that you're declaring a new variable called bad indices, and
Yes.
you're putting indices into there from those two stacks.
Exactly. All right, what other questions do you all have about this before we translate it into code? Okay, in that case, I'm just going to get started. So first step, define right stack and left stack as empty arrays. So left stack equals an empty array. Right stack also equals an empty array. Iterate through the string. So because the indexes of this matter, I can use a method to make sure I can compare both the... There are two ways I can do this, right? What are the two ways I can do to make sure I know what the index numbers are for each item in this when I do my for loop?
Can you use enumerate?
I can. So I can say for index and char in enumerate string. And so that defines two variables here, index and character. Index will give me the index of each value as I iterate through, and character will give me the value. And that allows me to do that when I use the enumerate method. Makes it very useful for problems like this. All right, so we have if the character is a left parens, if the character is a right parens. If it's not either of those, we don't even need to worry about it. So you say if char equals a left parens. We say left stack dot append. And we want to append the index number, not the character itself. And then we can say elif the char equals a right parens. Then we need to say, okay, we need to check if there is a matching left parens. Meaning, okay, if there's anything in left stack, we need to remove the last thing that got added to it. So how can I check if left stack has any values in it?
You could just do if right stack. If it has stuff in it, it'll evaluate as true.
Yeah, so I do if left stack.
Yeah.
An empty array will evaluate to false as falsy. An array with anything in it will evaluate to truthy. So I can just do if left stack. And if so, I want to remove the last thing that got added to it. And how can I remove just the last value from an array?
Pop.
Yep, dot pop. So I'm going to do left stack dot pop. And dot pop just removes the last value in an array. And then I can say else. So if there isn't, if it does not have anything in it, meaning that there is no matching no matching left parens, then I'm going to add to the right stack dot append index. So I'm actually going to add some test code here just to see what this looks like at the end of the day. So I do print. I'm going to kind of demonstrate it a little bit. So left stack should be left stack. Gonna add a new line character. Right stack will look like right stack. So now just to try this out, I'm going to run it. So I'm going to say print out. Actually, I don't even need to print out. I just need to run balance. And I'll use this particular string as an example. Like so. So if I run Python balance parentheses .py. So left stack has 9 as, position 10. So 0, let's go over here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because this is a bad one. And right stack has 9 because this one is also not matched. All right. What questions do you have about this kind of enumeration that we just did? All right. So now we go through that loop. Then we need to say bad indices are equal to left stack plus right stack. And the cool thing about Python is you can literally write it like that. So you could say bad indices equals left stack plus right stack, and that'll just combine our two arrays. Then we define a return string as an empty string. So return string equals that. All right, and then we need to, once again, iterate through our string and check all of the indexes against bad indices. So I can once again do for index char in enumerate string. And I can just say if index not in bad indices, return string plus equals the character. So I go through this and just say, okay, 0, 1, 2, 3. If as long as it's not in bad indices, I don't need to worry. I can just add it to the string as normal. And then at the end, I return my return string. So how does this solution look?
A lot better than mine.
Yeah. Mm-hmm.
All right, so I'm going to run my spec file. Uh-oh, I got an error. Ah, I can see right here, I think that was a problem with that. Ah, yeah, I misplaced a parens in the wrong way, like so. All right, so now if I run it again, all right, I passed all of my tests. So again, this method is something that I got to after like attacking this problem like several times over the years. So I'm not saying, you know, okay, this is not the obvious solution. This is just the solution that I found that works best. And if you see it again in a coding interview, you will now recognize it and know that you can use stacks. So yeah, what questions do you have about balanced parentheses? Or does anyone have another solution that they think is more efficient or more clear?
I actually have a question, Noah.
Yeah.
How did you figure out about stacks, or how did that become a thing that even you found out about or thought to do?
Good question. So I encountered stacks when I was in my coding bootcamp, actually, but it wasn't actually taught by the regular curriculum that we normally did. It was actually something that one of my instructors assigned to me as like a post-graduation challenge, is to understand other data structures. And so that's where I first encountered the concept of a stack. And I kind of recognized that a stack was as a solution to this problem when I did this as a whiteboarding challenge when I first interviewed for Code Platoon. Essentially, I went through this, and with a little help from John and Tom, realized that, okay, I only need to care about the last thing that we looked at. So keep on checking, is the last left parens we added a matcher to the next right parens we encounter? And so that I realized was the last in, first out problem. So this solution kind of came from a long time of seeing patterns in coding. This is something that you start to recognize as you get experience.
Another question about stacks. Stacks are just arrays that you treat in a certain way, right? I mean, you just declared an array, or is there something about the way you declared it that
Mhm.
is unique from the way an array works?
Yeah, so I am just declaring these as regular arrays. In other coding languages, a stack is more of a formal data type. So if you wanted to, like, I couldn't tell you what language off the top of my head, but other languages, you'd like, if you had declared a stack, you would not be able to do anything but remove the last one. So essentially, I am treating an array as a stack, but I am not. It's not a formal data type at this time.
Yeah, there's essentially data structures that only operate in very specific ways.
Yeah,
There's
because
stacks, there's queues.
Mhm. Yeah, and we're gonna, as we go through this, we'll teach you other data structures that won't necessarily come up in our challenges, but do exist. Like the opposite of a stack is called a queue. And instead of being last in, first out, that one's first in, first out. And there are other things like linked lists, etc. So you're going to encounter these as we go on.
No, do you mind if I see the bottom of your code?
Yeah.
From 2400. Yeah, that's good. Thank you.
Yeah, I have one more quick question.
Yeah.
If we, for instance, I struggled with this problem, is it acceptable for us to work along with you in our Visual Studio Code while we're working through this together?
Definitely.
Okay. Thank you.
Yeah. My only request is that you don't try to make sure you're also listening to me as opposed to just writing what I write.
Absolutely.
Because I've had students in the past who were so focused on copying my solution that they didn't understand it at the end of it.
Thank you.
No problem. Okay. Any other questions about balanced parentheses? All right, let's see here. It's now 9:53. So let's take another 10-minute break. Be back here at 10:03, and we will get started on covering object-oriented programming.